The standard normal distribution, also known as a bell-shaped curve, is a normal probability distribution with a mean or mu of 0 and a standard deviation or sigma of 1. The total area under the curve is equal to 1. So when we look at a normal curve, this curve here, if you were to add up all the area underneath the blue curve here, it would add up to 1. We have our mu, our mean, right here, right in the middle, perfectly cutting this half from this half. So 50% here and 50% here. If you're actually curious to know what the formula is that makes this curve, here it is right here. That whole thing, when used properly, will give you this curve here. Typically, we don't have to memorize it or use it, but if you're curious to know what it is, here it is. So even though we are saying the area under the curve is equal to 1, we're actually saying there's a correspondence between area and probability. When we talk about the area under the curve, we are actually essentially saying finding the probability. So there's no confusion whatsoever. When we say area, we are saying probability. We are saying probability, we are saying area. They are synonymous. They are equal to each other. So don't confuse the two. They mean the same thing in this context. To find the area or probability of a normal curve, we actually have to use a z-score formula. The z-scores help us find the probability and area. In this formula here, z equals x, some particular value, minus mu, our mean, divided by sigma, our standard deviation. When using the z-score formula to find z, we are taking our z and we're going to use it to find the area and or probability. Again, they both mean the same thing. Make sure that you know there's a big difference between z-score and area. They are not the same thing. Z-score helps us find the area, and area can help us find the z-score, but they are not equal. They are not the same. And if you confuse the two, you will get wrong answers. So be mindful. Z-score helps us find area, and area can help us find z-scores.